Hello everyone and welcome back to another troubleshooting video. And if you now go like, wait, I know this card, hasn't he worked on that one before? No, I haven't. This is the original one, which I made already a modding video about. And this one is another identical model of the GTX 760 192-bit. And this one's also described as no image. So today we'll be troubleshooting this one, not the other one. That one's already done. That card is intermittent and probably has a dying memory module, but works for now. So, first physical inspection. PCI Express bypass capacitors look good. So that's not the reason for no detect. Otherwise, I don't see any major defects. If this is just a dead HDMI port again, I'm gonna be very happy. It's not gonna make for a very good video, but I will get a working card. Okay, I don't see anything. Let's take off the shroud, or just the entire fan assembly. One thing I noticed with the other card is that someone did disassemble this before and put the screws back in wrong, because all the screws on this card have the same thread for the fan assembly, but some of them are countersunk and some of them are flat. And the flat ones are supposed to be going into the PCB, whereas the countersunk ones are meant to go in like these holes right here. And I did find some countersunk ones in the PCB on the other card. This one so far seems fine. There's no warranty sticker, so I can't really tell if this has been disassembled before. Yeah. This one is a bit hard to get out. The heatsink kind of like hangs on that piece. But you can kind of like... Yeah, it's very, very finicky. I don't really want to remove the heatsink right now. Is there something? No, there's nothing loose in there. This one's harder to get out than the other one. The other one also had a bent heatsink. The caps in here seem kinda brownish. Please don't tell me this was heat gunned. If this was heat gunned, then I'm just... I bought this guy from a person who also had a RTX 3060 Ti listed. And that's the only listing they had. So this was probably their old card or something. Or they were a miner and just have this one. Okay, come. Where is it hanging? Something is hanging somewhere, but there's no screw. So where the hell is it hanging? There we go. Okay, it is quite a lot dustier, and I think that bend in the heatsink is actually wanted. Yeah, there's quite some dust in this one. The other one had a dusty PCB, but the fan assembly was actually like pretty clean. Okay. Well, this thing doesn't have fuses, so... Yeah, those capacitors are like... yellowish, brownish. Let's take a look at the core. This one might have been heat gunned. This is also like... Well, I can't compare to the other card now because the other card is soaked in flux and that also browned to the sticker, but this used to be like... I think this is also a bit darker than it was on the other card. Oh boy. Please don't let this be another no fix because someone destroyed the card with a heat gun. I really should make that video. I see far too many cards that have been obviously heat gunned and just destroyed so that it's no longer worth even attempting to fix them. To let this pass. I've been thinking about making just like an angry rant video about what exactly not... What the hell is this? Yeah, that's not factory thermal paste. What the hell is this? Like, this is what it's supposed to look like, and then there's... Does this have water damage? And then the front too. Is that like rust or something? I don't see any bubbles on the substrate. Okay, let's get the VRM heatsink off and then I'll clean the core and take a closer look at whether we will have some burnt underfill. That's a good way to see if a card was heat gunned, because usually the underfill, if you don't know what it is, I'll show you. Usually that like darkens around the core when it's heat gunned. It also darkens when a specific part of the memory controller dies. Yuck. That's okay. The other card was cleaner on the inside. This one is cleaner on the outside. This one's also... I wonder if this just like was in a very humid space, maybe. Okay, I'll get some toilet paper and clean this thermal paste off. GK104, 200 KDA2, same die we have on the other one. If you didn't know, the KD means that memory bank D is disabled on this card, because it's a 192-bit version of the card. That looks fine, actually. So the underfill is this stuff around the core, and you can see it's like grayish. That's fine. If it's like brown, then something has burned. Okay, so physical inspection as far as it goes. Like these capacitors and like that looks a bit weird, but there's no burn damage that I can tell. So let's get out the multimeter. So we're doing the standard checks. No, actually, let's first put into diode mode. So when the two things meet, they beep. So if something is connected that shouldn't be connected, we get a beep out of it. And let's first go. So, standard checks. I always like to explain this. We check our power inputs. We have the PCI Express slot, which provides 12 volts on the first 3 pins on the left. And it also provides 3.3 volts on the 4th pin from the right. And then we have a 6 pin, which only provides 12 volts. We need to check all of those individually. So let's get the I/O shield, test the ground pin of the 6 pin for, yes, we do get a beep from the ground shield, and let's check 12 volt PCIe. That one's okay. 3.3 volt, 1, 2, 3, 4. That one's also okay. Now check the 12 volt legs, which are these. Also okay. So we don't have a short on any of the power inputs. At this point you can turn the card on. You can do some more checks. You could, yeah, let's actually do that. One thing that you can do is measure the voltage drop. So you go into diode mode again, and you measure the PCI Express data lines. So you measure the first two and then a random one, and if all of those have a similar voltage drop, then that's good. If they have a different voltage drop, then you probably have a dead core. How do I actually find the data lines? I can't really see them. Okay. 607. 619, that's still within tolerance. Let's check a random one. 575. Okay, those are still, like, it does change slightly, but like none of them are 0 or something, or like 200. That would be a bit much. Then we could also measure the. So if I've seen Text Cemetery do this. You can check the reference clock plus minus pins. You can check the PEX reset pins. If any of these are like short or anything, it also indicates a dead core. I'm not entirely sure where those pins are. I think one of them is like the very first pin right here. That's the PEX reset, I think, and then reference clock. I don't know where they are. I'm gonna forgo that because I don't think the core is dead on this. Like Kepler cards are not really known to have dead cores. If anything, they have dead memory or just missing rails. So yeah. So from the measurements we've made, well, actually we can still measure resistance. Let's do that before we turn it on. That's a step you don't have to do. It's just one that I like to do because it can help you with finding the problem. Usually it doesn't do anything for you, but I just like to include it. So let's measure the core resistance. 12 ohms, that's perfectly fine for a small die like this. And let's check the memory resistance. 114 ohms, that's normal. We have Hynix memory on this card just like the other card, and I think these have very similar results. Let's check the PEX rail, that's this little converter up here, and this should be the output pin. And I see a very similar resistance I did see on the other card. So that's fine. And then we have a 5-volt regulator over here, which I think the upper pin was the output. Let's just check. So we see 10 kilo ohms. The middle one is probably ground. Yes. And the other one, oh no, that might be the output. What resistance do we have? Wait, do we just have 1.7 kilo ohms on 12 volt PCIe? Like, that's not short, but it's a bit low. What does the 6-pin read? Yeah, that's much higher. Interesting. Okay, like the PCIe 12 volt is not specifically short, but it's a bit lower than what I would expect. So maybe there's like a partially shorted component on that rail, but that wouldn't cause no image, would it? Anyway, radar measurements. This one looks a bit suspicious, but it doesn't have to be a problem. So let's set the card up in a test bench and turn it on. The card is set up in a test bench, and we can turn it on. The GPU chip is being suspiciously cold, however. Yeah, I don't think we have vCore. Yeah, it's staying cold. Okay. Missing rail. Let's get the multimeter and see what else is missing. So we have a multimeter, the ground probe is connected to the PCI Express slot here, and we're just gonna see all our voltages. So to reconfirm, we have a little bit of vCore, but that's not enough for the card to do anything. And for the memory, those are SMD inductors, I have to probe it here. We do have our memory voltage. Do we have 5 volts? We have 5 volts. Do we have PEX? Let's get that in. We have PEX, but too low. PEX is supposed to be at slightly over a volt, which is interesting because we do have memory voltage. And the PEX rail on the card, as far as I know, takes the memory voltage and then converts it down to slightly above 1 volt. But as you can see, the PEX voltage is also too low. We just got 500 millivolts. We are supposed to get slightly above 1 volt. And then vCore obviously is completely dead. Or I mean... No, actually. I'm just being dumb. No, we do have vCore. We don't have PEX. And the chip isn't heating up because I guess it's not doing anything. No, yeah, sorry. We do have vCore. The error I made is I set it to the 20 volt regime to measure the 5 volt rail, not the 2 volt regime, which is what I usually use to measure things. And I saw a 0 point something and was like, no, that's just 100 millivolts. But actually, we have 900 millivolts, which is the idle voltage for this card. I've seen it on the other one, these idle very low in voltage. So we do have vCore. And the core, I mean, yeah, it is actually getting warm now, it's just taking a while. So the actual problem is this PEX rail right here, which is at about half the voltage that it should be. So, it seems we have our diagnosis. I'm probably actually have one of those chips harvested from another card. I'll take a quick look if there's maybe any damaged capacitors around that thing that I missed. But I'm pretty sure that this chip is our culprit, that this is just broken, needs to be replaced. I've had that before, dead PEX rails on Kepler NVIDIA cards. So I might have a replacement for this from a donor card that I can put on, and then the card could very possibly just work. So I'll see to that. And so actually, before we just blindly remove and add things to the card, let's just check the chip properly. So here's the pinout for this chip. This is a GS7103. I've seen a fair amount of people deal with dead examples of this chip. So it's not too surprising that I finally also ended up with one. So what we're gonna do is... that probe is not in a good spot. Yeah, so we'll check a few things about the chip and see if it's not something external before we actually put in the work to replace that chip. Specifically, we will check enable, we'll check voltage in, and that should actually be it. This is also the VDD pin. I am not entirely sure what it does. Supply voltage for control circuit. Okay, that is important. Yeah, okay, so VDD is the power for the chip. Vin is just the memory voltage. Because Vin is the voltage that it converts down, and then the enable signal enables the chip. And then our Vout pin down here is the output that we can check, but we already know that that one has problems. So, let's recheck if it's not just intermittent. Nope. Okay, so enable, we have 5 volts, so enable is good. Vin, 1.5 volts, which is just the memory voltage, not too surprising. And 5 volts again for VDD, so the chip is getting power. So the chip should have everything it needs. No connect, Vout. I don't know what this pin does. It's at 1 volt. What does the data sheet say? POC. Open drain output, setting high impedance once Vout reaches 92% of this rating voltage. Okay. Yeah, and then you have the out. So this is a no connect pin. This is ground. This one is the output, which you can see is too low. And then this is the feedback pin, which, well, has the same voltage on it because it's the feedback pin. So, yeah, I'm staying by the diagnosis that the chip itself is just dead. So I'm gonna look for a donor card that has this on it, and then just replace it, and hopefully the card works again after that. So, as you just saw, the GS7103 has been replaced, the card has been reassembled, and is now working just fine. All 16 lanes detected, and, well, it's the exact same spec as this card over here, so there's nothing new here. But the card works just fine. We get the voltage we should get, we get the clock speeds we should get. Power consumption looks alright. So, I'm gonna consider this card fixed. This is a proper repair. This is probably the most proper repair I've done so far, because it did not result in any capacitors or something missing from the card, which is what I did on the 680 the last time. This one, just a simple minor rail converter swap from a donor card, and now the card works just fine. This is a really nice and proper repair. This is exactly what I wanna get when I buy these dead cards on eBay. I wanna get something that isn't like, yeah, it is a repair that I can do. It's not just like a dead memory module and I'm just gonna have to throw it on the pile until I eventually get around to swapping memory modules. So yeah, so it's not something super obvious, just like, oh yeah, there's a dead MOSFET there. You really have to go through the troubleshooting sort of algorithm to get through this problem, but we did. It was still a fairly obvious one. But then again, I like how this went. The card works now. So yeah, thank you all for watching. I hope you enjoyed the video. I hope you learned something. And until next time, goodbye.